Today I'm going to take you through integration and the basic formulas. So we know there's this process called differentiation, and this is when we go from f of x to f dash x. Well, integration is actually just going this other direction, where you've got f dash x and we're going back to fx. So it's a reverse process, and it's also called anti-differentiation. If we have a look at an example of this, we'll take this example of a third x cubed plus 6. Now, when we differentiate it, it's going to give us x squared. Now, and there was nothing that gave it on the end because the plus 6 goes to 0. So basically, you've got this thought then that if I've got x squared, that would become a third x cubed. But notice that we didn't actually have just a third x cubed. We had this 6 on the end. So we had this constant. So the way in which we deal with this when we differentiate is we're actually going to add on a constant. And we call this constant c. So this means that when we are to integrate x squared, not only do we write the third x cubed, but we add on this plus c. Okay, and this c is a constant. So let's look at some of the rules. Now I'm going to take you through these rules. I'm going to take you through these basic rules, but I'm going to take you through it a different way. So if I have y equals 2x, right, I'm going to take you through the rules, the basic rules, but I'm going to do it by looking at what happens when we differentiate. So if we've got I'm going to take you through the basic rules of differentiating, but I'm going to do it backwards. I'm going to go by showing you what happens when we differentiate. So if we've got this value 7x, when I differentiate, it goes to 7. So this makes sense if I've got a value, a number, that when I integrate, it's basically going to add on that x. Now, if I do x squared, basically what happens is I put the 2 out the front, and I take 1 off the power. So it makes sense if I'm going this other direction that I'm obviously adding 1 to the power and I need to divide it by that new power n plus 1. Now e to the x when I differentiate goes to e to the x, so obviously it makes sense that when I'm going the other direction I go to e to the x. When I have ln of x, then when I differentiate, that goes to 1 on x. So again, it makes sense that when I go from 1 on x, it's going to give me ln of x. Now, when I go from sine x and differentiate, that's cos x. It makes sense from when I'm going to the derivative back to the original, it's just going to give me sine x. And lastly, when I do cos x and I differentiate that, that gives me minus sine x, which means when I integrate sine x, it's obviously going to give me a minus cos x the other direction. So let's do some examples. So you'll notice that we have this symbol. This is telling us to integrate with respect to x. Okay, so as I said, let's start with the first one. We add 1 to the power to become 4, and we divide by that new power. We do the next one. Again, we add 1 to the power, and we're going to divide by that new power. Remember, we've got a constant, which means with a constant, all we're going to do is add on the x, because technically we've got a 1 here, and we divide it by 1, which we know is just 5x. So we don't necessarily need to write all those bits in. Now, what we need to remember is at all times at the end, we need to add on that constant. Okay, let's do with the second one. With this second one, what you need to start with is you need to write it as a negative power and powers to the half so that we can do this process. So once again, we take the first one, we add on a power. So obviously when you add on 1 to -3, it becomes -2. And we're going to divide by the -2. We do the same with this power to the half. When we add on 1, it's going to become 3 on 2. And therefore, we are going to divide by 3 on 2. And we're going to add on our C at the end. We can certainly simplify this to be -1 over 2x squared, take away 2/3 x to the 3 on 2 plus c if you need to go on and use it. Let's do the next one. Now, when we differentiate this one, remember when the sine x when we integrate this one, this rule is of the fact that sine x goes to minus cos. So it's just going to become -2 cos x. Take away cos goes to sine. And then we're going to add a c on the end. Okay, if we look at this next one, 3e to the x simply becomes 3e to the x because e to the x goes to e to the x. And take 4e to the x, same deal. It's just going to be -4e to the x, and we add on a c. Okay, so there's some basic ones done. Let's do some more. They're going to be a little bit harder this time. Now, the thing about this is we do not have a product or a quotient rule like we do when we differentiate, which means we often have to be able to expand this before we can do this process of integration. So first of all, I'm going to expand this, which becomes 9x squared plus 2 times 3x times 2 on x plus 4 over x squared. I'm going to simplify this to make it easier. And once I've simplified it, I can actually start to integrate it. Now, if I integrate it, once again, remember that we're adding 1 to the power and we're dividing by that new power. When it's just a constant, we just add on an x. Again, with this one, we add on to the power, but remember when it's a negative, -2 plus 1 is actually -1. We divide by that new power, and I add on a c at the end. I can certainly reduce this. And off I go. Right, let's do this next one. Once again, we have to simplify it. We're going to attach the x to the half to each part of this top. Okay, and then that way we will be able to integrate. Now, when we integrate, once again, we're obviously adding on 1 and we're dealing with fractions. And we add on our plus c at the end. Once again, we can certainly reduce this